We are pleased to present you a report on the topic Design and Calculation of Multifunctional Canopies in the Form of Shallow Shells. Authors, Alexander Kolesnikov, Tatyana Tsurik, Sofia Kurakina, and Ksenia Litvinova. Large span canopies can be used as structures for various purposes. They have great imaginative potential and were originally designed as exhibition spaces to showcase achievements in the field of art, science and technology. The world practice of construction has accumulated extensive experience in the use of large-span structures by the most famous architects. The ancestor of this phenomenon can be considered World Trade exhibitions. For instance, in London in 1851, there was an exhibition located in the huge Crystal Palace, designed by Joseph Paxton, who used standard elements in the form of a factory cast iron grate filled with sheet glass, which eventually formed a greenhouse of enormous size. Paxton's Crystal Palace was characterized by the maximum use of the materials which became available. The structure, 563 meters long and 124 meters wide, clearly demonstrated the metal architectural possibilities. Metal trusses with a cross lattice were used for the floors. The most difficult structure for design and calculation in the considered multifunctional canopy is a cover in the form of a shallow shell with a skylight. The task of calculating the roofing of buildings and structures in the form of shallow shells with a skylight in an arbitrary section with any aspect ratio in the plan and type of support, as well as loaded with a vertical uniformly distributed load, can be represented by a system of equations 1. At the same time, the thickness of the structure is relatively small compared to the dimensions in the plan, and the deflections are commensurate with the thickness. Therefore, it is necessary to take into account the geometric nonlinearity of the structure. The slide shows system of equations, where phi is the stress function, W is the deflection function, F is the median surface function, Z is the load function. The skylight is modeled as a change in the modulus of elasticity on an arbitrary area of the structure in the following way: equations 3, where E stands for initial modulus of elasticity, nu and gamma, coefficients characterizing the skylight size, 0, A, M, coefficient characterizing the displacement of the center of the skylight along the x-axis, N, coefficient characterizing the displacement of the center of the skylight along the y-axis, theta, coefficients characterizing the shape of the skylight faces along the x. The slide shows shape and location of the hole depending on the variation of parameters m, eta, theta. Variation of the coefficients m, eta, theta gives the opportunity to set a large number of options for possible cuts, their location, size and shape of the faces. Since the structures under consideration can be attributed to thin shallow shells, the thickness is much less than the planned dimensions. In most cases it becomes necessary to check the structure for stability. The critical load factor for shallow shells can be represented by the equation 4. The values obtained using the presented method were compared with the results of other authors. The results of the solution showed good convergence with the values of the authors using other numerical methods. When calculating by the finite element method, the result strongly depended on the number of finite elements used in the model. For example, we considered the construction of a coating in the form of a shell on a square plan with a ratio of thickness to size in plan HA equals 1/10. Figure 4 shows a decrease in the value of the critical load of a thin-walled coating structure, determined by formula 4, with an increase in the parameter m, i.e., displacement of the hole from the center to the edge of the structure. The figure clearly illustrates the decrease in the strength characteristics of shells as the skylight approaches the support zone and the possibility of using the above equations to determine the stress-strain state in them. The graphs 5 show the possibility of using the presented numerical technique for determining the stress-strain state of structures in the form of shallow shells to analyze the influence of various cutout parameters, location, size, shape of the hole edges, and structure dimensions, thickness, structure shape, lifting boom, on the studied characteristics. The technique for determining the stress-strain state of structures in the form of shallow shells with cutouts makes it possible to conduct research and evaluate the bearing capacity of a structure based on design conditions. The representation of equations 4, in a dimensionless form is convenient for obtaining dependencies and analyzing the changes introduced without reference to specific dimensions. Setting the function of the middle surface f, which is included in the system 1, in the form of a transfer surface, made it possible to study the effect of a skylight on structures of various shapes with the same dimensions in plan and lifting boom. For structures in the form of shallow shells with a generatrix in the form located between the spherical and chain functions, the influence of defects on the value of the critical load is manifested to a lesser extent. Graph 4 shows the effect of notch placement on the critical load value, as the most important defect parameter after its value, the influence of which is obvious. Figure 5. It allows us to evaluate the degree of reduction in the bearing capacity, depending on the approach of the cutout to the support zone. The analysis of these parameters, along with the characteristics of the structure shape and thickness distribution along the generatrix, makes it possible to achieve the best values of the critical load for given design parameters. It is possible to reduce the value of the influence of the cutout by giving a shape close to optimal at the design stage of the structure or by setting a rational change in the thickness of the structure along its generatrix. The proposed design of canopies makes it possible to erect structures with a changing functional purpose. The presented technique can be used to determine and study the stress-strain state of structures in the form of shallow shells, taking into account the geometric nonlinearity of work in the presence of cutouts in them. The constructed graphs of the dependence of the critical load on various parameters made it possible to evaluate the operation of structures, taking into account changes in various factors of skylights. The use of varying characteristics of cuts allows you to get results that are close to real conditions. Thanks for your attention.